All right, hey, we are starting our lesson of transformations. Each of these following will describe a transformation of a graph. I'm going to show you the three types of parent functions that we'll be dealing with in class. And if you need anything, because this is a live, just note that you are going to be recorded for future people to see. Okay? So first off, before we even begin with transformations, there are three different types of graphs in this class that we kind of talk about or we kind of look at shape-wise. We call these parent functions. Because they are the parent that we base all the transformations off of. So the first one, hopefully everybody's familiar with, this is f of x is equal to x squared. This graph is simply a U-shape. The next one is an absolute value graph, which is in the shape of a V. And then the last one is the square root. No problem. Take as many as you need. Yep. And then this last one here is the square root packet, or the square root function. Remember, radicals cannot have a negative underneath, so anything that you see has to be kind of in the positive range. Those are the three parent functions that we'll talk about. We'll discuss things such as shifting up and down, which is when you have a vertical. Okay, anything outside of a square or an absolute value symbol or a radical is what we consider a vertical movement. Anything on the inside is what we call a horizontal movement. Horizontal movements are a little bit different because with a horizontal movement, sometimes we have things like horizontal compressions and horizontal stretches, which are by factors of 1 over whatever 1 over the number that we're given. Okay? And I'm going to show you examples of all these different types throughout the notes today. But I mainly want you to take a look at these two right here. Okay. Anything inside moves left and right. Anything outside moves up and down. But these in particular, outside, if it's greater than 1, it's a vertical stretch. If it's less than 1 but greater than 0, it's a vertical compression. And then we flip-flop. If it's greater than 1 on the inside, it's a horizontal compression. If it's between 0 and 1, it's a horizontal stretch. And note the factors 1 over whatever that number is going to be. We also have down here reflections. So for instance, y is equal to negative f of x reflects across the x-axis. This is what we call a vertical reflection. And then whenever the negative is on the inside, it's a horizontal reflection. All right, so correct order to describe multiple transformations usually start with the groupings of any type of multiplication and division, any type of reflections, and then we go with the addition and subtraction, moving left to right or up and down. So I'm going to show you the graph. You don't necessarily need to know the graph for this lesson, but in other lessons we'll talk more about the graph. But I want to show you because I know some of your visual learners. So we start with the parent function, f of x, absolute value of x, and then we move into the parent function's change, which is g of x is absolute value of x minus 3. Note, because this is a minus 3 on the outside, this is a vertical movement. So we would say that this is a vertical shift down 3. Kind of show you what this graph would look like. The absolute value. And then if I was to shift it down 3, 1, 2, 3, and then it would pretty much just be the same. So what I'm going to ask you to do is what's in green right there, which is tell me verbally or on through whatever we're using what type of shift you're going to have or what type of movement. Take a look at example number 2, for instance. Notice how this is different. The 2 is on the inside of the parentheses. This 2 would make this a horizontal shift. And with horizontal shifts, it's kind of a little bit backwards. You're thinking, okay, +2, so I'm actually going to go to the right. But in reality, because this is +2, it's horizontal and moving to the left. So horizontal shift left 3, or left 2. And if you ever have any questions about this, take a look at plugging both of those into your graphing calculator, and you'll be able to see the difference. So this is x squared. It's your f of x function. And then with the other one, we shift left 2. So that's your g of x. Give me a second if you want to copy this down. There are 10 examples today. Some of them are, I'm going to show you a little bit different, what I like to call part 2. We won't get there for a minute. What happens when you have multiple transformations? Okay, I'm going to use different colors to kind of show you what those multiple transformations are. Again, because this is a radical, our parent function is going to look like this. Okay, so picture that in your mind, and now you've got all these different changes going on. First off, you've got to change out front of your radical. That is between 0 and 1. Since it's outside, it's vertical, and it's multiplication. This change is a vertical stretch, or I'm sorry, vertical compression. By a factor of 2/3. With the vertical, we always keep the factor as the same number that was out front. Our next thing is that we have this negative on the inside. This would be a horizontal reflection. And that would create a mirror over the y-axis. Last but not least, I'm going to do this one and do it in gray here. We've got that -1 on the inside. That's also going to be horizontal, so it will be a horizontal shift. We call those translations, by the way. Shift right 1. So how this works, first thing I'm going to do is I'm going to actually look. I've got a vertical compression by 2/3. It means it's going to be a little smaller. It's over the y-axis, and I also shift right 1. So let me shift right 1. A little bit more closer to that axis. It's going to be going the opposite way because of the reflection. Example number 4, f of x. Again, another radical. This time we have 3/4 inside and then a +2 on the outside. So let's kind of dive into what that looks like. Again, we're talking about radicals, so I'm just going to draw my f of x graph here, just a rough sketch to kind of see what we're talking about. Now, here's the deal. Because this is on the inside, this is something new for us. This is actually what we would call horizontal stretch. Even though the numbers between 0 and 1, with horizontal, we would actually flip it. It'd be a reciprocal. So therefore, it becomes a stretch. So this is going to be a horizontal stretch. by a factor of, if we did this by the book, it'd be 1 over 3/4, which is really 4/3. And again, I'm showing you this because a horizontal stretch and a vertical compression are very, very similar. It's just all depending on where you're pulling from. So vertical and then horizontal. I'm showing that with my hands. Of course, you guys can't see me on the screen for the video. And then because it's on the outside, that is a vertical shift up 2. So 1, 2. It would look a little bit, just a little bit stretched. Like I said, I'm just doing the rough sketch so you can kind of see where some of the transformations occur. If anybody has any questions at all or needs me to slow down, just let me know. But we're going to move to example number 5. Take a look at example number 5 here. This is the last one I'm going to do, and then I'm going to have you try a couple just to kind of cement this in. We've got the negative on the outside. This is something different again. This is a vertical reflection. Vertical reflections are over the x-axis. And then we've also got the 2 on the inside. That means it's horizontal. So it's a horizontal shift right 2. Okay, so again, you've got this original equation. Thank you. Right there, x. And then you've got the movements here, vertical, and then we also go right 2, 1, 2, and over that axis. Oh, and I mislabeled that, so let me label it correctly. That's f of x, and that is g of x. All right, what I'm going to have you do is I'm just going to take a pause for a second. I'm going to have you guys try examples 6 and 7. I'm going to leave it run. You can always fast forward if you're on the video. You can always fast forward through it, but I'm just going to give you a minute or two to try those problems. We'll go over them, and then we'll do 8 through 10, which are a little bit different. So just kind of, you don't have to write anything down if you don't want to, but at least kind of take a look at them, see what you got. And just put it all down. All right, coming back to this, notice that you've got a couple different changes here. The first one, hopefully you saw that that's on the outside. That is a vertical reflection. The 2 that's on the inside, that is a horizontal shift. Right 2. And then the one on the outside, that is going to be a vertical shift up 1. Okay, so I'm going to show you here what this would look like. Obviously, absolute value, what f of x would look like. Rough sketches, like I said. I'm not getting into too much detail with points right now. I would go to the right 2. I go up 1, probably where my vertex would be. And then I need everything to be a reflection. And like I said, rough estimate / sketch of where that problem would look like, what that would look like. Right, and then example number 7. 3 is actually on the outside, so this 3 would be a vertical stretch by a factor of 3. And then it would also be a vertical shift up 4. Rough sketch there. Like I said, we're going to go up 4. Also going to go a little bit, multiply by 3. Real skinnier probably than that, close to the y. Essentially what you're doing point-wise, by the way, is you're multiplying all of your points by 3, all of your y values, since that's vertical, and then you're adding 4 to each of those. We'll get into a little bit more of that next time. It's more of a skill for a different class as well. But that kind of wraps up one of the skill sets that you should have for this lesson. The other skill set is what happens if you're not given the equation? What happens if you're just given the words? Can you create the equation? So take a look at this, example 8. It says the graph of f of x is equal to the square root of x. It's vertically compressed by a factor of 1/5, and then we shift up 3 units. So first off, we're going to start with that parent function. F of x is equal to the square root of x. And then we're going to look at what vertical compressed by a factor of 1/5 actually means. Vertical means that it's going to go on the outside of our radical. Because it's a compression of 1/5, it means that we're using multiplication. So we're then turning our f of x is equal to the square root of x into f of x is equal to 1/5 square root of x. And then it says shifted up 3 units. That's also a y move or an outside move. So it'd be f of x is equal to 1/5 square root of x plus 3. That would be our final result. All right, example number 9. I did want to show you one of each of these here. The graph of f of x is equal to the absolute value of x, horizontally stretched by a factor of 6, reflected over the x-axis, and then shifted down 2 units. First thing that we are moving is that this is our parent function. The next thing that we want to take a look at is it says it's horizontally stretched by a factor of 6. What that would mean then is because we use the 1 over the reciprocal, this would change into f of x equals absolute value of 1/6x, because we have to include it on the inside. A reflection over the x-axis is a vertical reflection, so that goes on the outside. So f of x equals negative 1/6x. And then shifted 2 units down, that's also going to be on the outside here. When I say outside, I mean outside of the 2 lines that create the absolute value. It's negative absolute value of 1/6x minus 2. All right, our final example here. The graph of f of x is equal to x squared, vertically stretched by a factor of 2 and shifted right 1 unit. Again, we start with our parent function, f of x is equal to x squared. Vertically stretched by a factor of 2. That goes on the outside of the x squared, so just be 2x squared. And then shifted right 1 unit. That shifted right 1 unit, that means that we're going to have a 1 on the inside. And because it's right and it's a horizontal movement, we're actually going to have a negative 1 on the inside as well. So this is going to now become f of x equals 2 times x minus 1 squared. With that, that's the lesson for today. Turn off the